Good morning, all. Good morning, students. Good morning, all. Guys, do you hear me? Right, yeah. So we'll start the class, okay? So yesterday we have started a new module, so which is on thin cylinders. So actually this module consists with the thick and thin cylinders, okay? So this will be majorly useful to design your cylinder based on the stresses which are acting within it, okay? So that is how you this particular module is going to be important in designing few elements, few applications like steam boilers, air compressors, tanks, water tanks, or a huge vessels, okay? So these are the ones so which are going to be designed based on the failures which are going to be happened in the cylinders, like longitudinal failures, circumferential failure, okay, or even the radial failure, okay? So these are all gonna happen just because of the stresses which are acting within the cylinder, okay? So that is how this module is going to be useful to design these applications. Okay, so let's share the screen. Okay, so 1 second. Yeah. So yesterday we have started with the module thin cylinders. Okay. So even we gone through what is the difference between thin and thick. Why a cylinder is considered as a thin cylinder? It is based on the few parameters. Okay. So thin cylinders are one which is based on its diameter. Okay, and its wall thickness. Okay, and it is based on the internal pressure which is acting in the cylinder and the stresses as well. Okay, so that is how the thin cylinders and thick cylinders are classified based on the few parameters. Okay, let's see in depth how these pressure, how these stresses are going to be considered in the thin cylinders. Okay, so first of all, let's go with the thin cylinder. Yesterday I have shown you a video how the stresses are going to be act and what are the real applications of the thin cylinders. Okay, so in many engineering applications, basically cylinders are frequently used to transport or to store liquids, gases, or even the fluids also. So I think you people have a clear definition between liquid and fluids, isn't it? Okay, so how can you define or how can you differentiate this liquid and fluid among? So basically fluid is a common substance, so where the fluids can flow with some viscosity, isn't it? So fluids will have a definite shape, but coming to liquid also will flow, but with a specific volume, but it won't have it won't have a not a definite shape. So that is how liquid fluids are almost equal, but coming to the viscosity level, fluids will have more viscous than the liquids. Okay, and coming to thin cylinder applications, pipes, boilers, storage tanks are all best examples for the thin cylinders. And basically these cylinders are subjected to huge pressure inside a cylinder. Either it may be a gas pressure or it might be a liquid pressure or a fluid pressure. And the cylinder is going to be subjected with a lot of internal pressure. That internal pressure will create three important stresses on matter. Okay, so please remember, whenever a cylinder is filled with some substance, okay, that substance will create lot of internal pressure. That internal pressure will create or will develop stresses within the cylinder. Those stresses are all mutually perpendicular planes. All these stresses won't act at the same point. Okay, they are not parallel. All these forces are mutually perpendicular to each other. How they are perpendicular? Let's see. And even you should concentrate on how these stresses are going to be act and what kind of failure these stresses are going to make in the cylinder అనేది కూడా మనం తెలుసుకోవాలి. Okay, so let's see first one. What are the three stresses? First one is hoop stress, hoop or circumferential stress under. Okay, so let's show you the picture. By that you can able to understand it clearly. So first of all, let's see the definition and then we will go on to the picture. So what is hoop stress? It is a direct stress, so which is tangent to the circumference. Okay, and basically the circumferential stress or a hoop stress is tensile in nature. I told you already, the pressure which is acting within the cylinder is going to, so see, the first one is this hoop stress or circumferential stress. Whatever the pressure which is acting in the cylinder will try to split this pressure will try to split the cylinder into few pieces. Kada eppudaina blast jarigindi anukondi emoutundi, the cylindrical parts will split. Whenever splitting happens, it is only happens because of tensile nature, because of tensile force. Okay, so that's how circumferential stress basically is tensile in nature. Very, very important. You need to underline that. And so thus there will be increase in diameter. Okay, so basically it depends on the diameter. Okay, and next one is longitudinal stress. So longitudinal stress will act along the length of the cylinder. Okay, so you can see here longitudinal stress. So here the longitudinal stress which is parallel to the length of the member. Avuna? So you can see. So this is the longitudinal stress. So this longitudinal stress is parallel to the length of the member. And basically, even this longitudinal stress, what it do? This pressure, I mean, whatever the fluid or gas or whatever it is, it will try to escape longitudinally. Kada? So from this part, it will try to escape. So when it is trying to escape, so what happens? So there will be longitudinal stress develop. That longitudinal stress will be in terms of tensile in nature. Okay, so that is the reason why longitudinal stress is also a direct stress, so which is depends on the length of the cylinder, and it is also a tensile in nature, and it depends on the length and matter. Okay, so the stress always depends on the length. So increase in length of the member meda longitudinal stress and depend avutundi. And the third one is radial stress. So what do you mean radial stress? Sorry, radial pressure antarama. It is not a stress. Radial pressure. So I think you all know the difference between stress and the pressure. Okay, so here the fluid or gas or a liquid, whatever it is developing within the cylinder, it will try to have a resistance as well. Kada? So it is a compressive in nature. See, longitudinal circumferential stress and longitudinal stress are both tensile in nature, but coming to excuse me. So, but coming to this, what is that? Radial pressure is compression in nature. It is compressive in nature. Okay, please try to remember this. Why it is compressive in nature? So, see, its magnitude is equal to the fluid pressure on the inside wall and 0 on the outer wall if it is open to atmosphere. What do you mean that? So, let us see. This is your cylinder. Okay, so which is having a definite thickness as it is a thin cylinder. Okay, so this, whatever the pressure which is acting from inside. Okay, when this pressure, whatever the gas or liquid, when it is trying to escape, what this internal layer or internal wall will try to do? Em chestundamma internal wall? What that internal wall will do? This is the pressure. This internal wall will try to push that gas or liquid towards inside. Kada? Push cheyaledu anukondi em jarugutundi? So there will be a blast taking place. Okay, so this internal wall will have a resistance towards the pressure in terms of what type of force it is. Ee rendu ఏ విధంగా యాక్ట్ అవుతున్నాయమ్మా? What type of nature it is? When two forces are towards each other.
Compressive, sir.
Very good. Compressive. Okay. So in that way, the radial pressure is in a form of a compressive nature. And very important point, what they are telling, if the cylinder is, and one more thing, whatever, will the outer wall will have any pressure? Inner wall pressure untunda, outer wall pressure untunda. Outer wall doesn't have any pressure. Why? Because the inner wall is only will try to resist the pressure which is acting inside the cylinder, and outer wall doesn't have any pressure. By that, the outer wall pressure will be zero. Okay, but when the outer wall will have a pressure, when this outer wall will have a pressure, everyone chappagalra? At this condition, obviously there is no pressure for the outer wall. When this outer wall will have a pressure, మనం ప్రాక్టికల్ గా ఆలోచించాలి. Any application do you remember? Even the outer wall will have a atmospheric pressure. Do you remember any example? Chondamma. So let us take this cylinder or a pipe which is fixed in a concrete. Okay, which is fixed in a concrete, right? Okay, so the pressure inside is something like a water. So where water is flowing, ardhamavutunda? So the internal wall will have a resistance equal magnitude. Let us take this P is some 300 Newton per mm square, and the resistance also will be same. Avuna? Then only your member will be equilibrium. Kada? This R. Okay. Now, taking the outer layer of the cylinder. This outer layer, earlier there is no atmospheric pressure, but now when this pipe is fixed inside the concrete, okay, so then tell me, will the outer layer will have a pressure or not? Outer layer ki pressure untunda undada? Yes or no? When this pipe is open to atmosphere, then the outer wall won't have any pressure. When this pipe is fixed within some constraint, so definitely there will be a pressure even on the outer wall. Ardhamavutunda? So that is what you need to understand. The radial pressure is varies based on the pipe, whether it is open to atmosphere or whether it is fixed within the closed conduct. అనేది మనం అర్థం చేసుకోవాలి. Okay, clear? Have you all understood what is the difference between circumferential stress, longitudinal stress and radial pressure? Please amma, మీరు ఓకే అంటే I can move forward. Yes? Clear? Guys, please respond amma. మీరు రెస్పాండ్ అవ్వకపోతే ఎలా చెప్పండి?
Yes, sir.
Yeah. See, మీరు ఒక్కరే రెస్పాండ్ అవుతున్నారు మా. What about others? Are they listening or not? Guys, others, are you listening or not?
I have a doubt, sir.
Hello? Hello? చెప్పండి, వింటున్నారా? అర్థమవుతుందా? See, if you're not responding, it won't be a mutual lecture. Okay, so here you can able to observe clearly. So this is the hoop stress, okay, and this is your longitudinal stress, and here you can see the radial stress or radial pressure. Okay, so pressure and stress and same amma. Why? Because both units are same. Okay, so load towards its cross sectional area gravity. So here you can see the internal wall will try to resist the internal pressure. So by that the compression force will develop here. So that is the reason why the radial stress is something like a compression in nature. Okay, and very important point, As I told you in the definition itself, the stresses, all these three stresses are mutually perpendicular to each other. And Japan, see, so this is your longitudinal stress, which is acting with respect to its length, and this is your circumferential stress, so which is acting along its circumference, and this is your radial stress, so which is acting in other direction, which is called as a z direction. Okay, as they are in three different directions, so obviously these three stresses are perpendicular to each other. Okay, so that is how these three stresses are going to be developed in thin cylinders. Okay, so element on the cylinder wall subjected to these three stresses. And so just I took a small element in the thin cylinder. From this element I can able to see how these three stresses are going to be acted. Okay, so very important few points we have to remember from this thin cylinders. One, hoop stress, it is a tensile in nature, it depends on its diameter. Second one, longitudinal stress is also tensile in nature, it depends on its length. Okay, third one, radial stress, it is compression nature, it depends on how long the radial distance of the cylinder. And one more thing, all these three stresses are mutually perpendicular to each other. Okay, so this is what you need to know before going into depth, how to calculate the hoop stress, longitudinal stress, and radial stress. Okay, apart from this, I have I would like to share you few important statements, okay, for your competitive exams. Okay, so let's try to write down them on the board. Okay, yeah. So few important points em cheptunnanu ante, so let us take a sphere. Okay, so because sphere is like a 3D structure, okay, 3D member, so which is also used for containing, you know, gas under pressure. Okay, even spheres are also used to store gases, okay, which is having a lot of pressure from inside. And basically liquids and gases which are going to be cause internal pressure in closed vessels are referred as fluids. We all know that. And coming to when it is a gas, okay, let us take a cylinder which is having a gas inside. Okay, so the pressure is constant in all the parts of the vessel. In this, what happens, you know, your pressure will be constant. Okay, so when a cylinder is having a gas inside, so the pressure is constant in all parts of the vessel. Pressure will be constant in all parts of the vessel. So this is let us take it as a vessel or whatever the cylinder is. Okay, so pressure is constant in every part. If you take at this point, the pressure will be same. If you take at this point, pressure will be same. Okay, so that is what you need to understand when the cylinders are filled with gas. And if the same cylinder which is filled with liquid, okay, so the pressure is low at the top and which is going to be more at the bottom. Okay, so pressure is lowest at the top and increases within the depth. Okay, so your pressure is not constant. Your pressure will be something like this, 0 at the bottom and maximum at top. Okay, ante, so let us take cross section of this cylinder. The cylinder యొక్క cross section తీసుకుంటే ఎలా ఉంటుంది? So like this. So that means, so if the liquid is placed here, ఎప్పుడైనా liquid 100% place చేస్తారమ్మా containers లో up to some level up. చెప్పండి. Guys, so please respond.
Up to some levels.
Up to some level, right? Okay. So when it is placed up to some level, if you see the pressure will be 0 at the top level and the maximum at bottom level, as it is a liquid. So manam dams, retaining walls chusam kada. In the same way, when the cylinder is when a container or when a vessel or any kind of tanks, when they are filled with water, the pressure will be 0 at bottom and the maximum at, 0 at top and the maximum at bottom anamata. Okay, so this is very important, where the pressure varies from low, that means 0 to maximum. Ade meeku gas anukondi emotundi, so gas is something like a, you know, it gonna occupy the whole space in the container, avuna antagani gas oka level varake untunda? No, it is going to be occupy the whole space of the cylinder or vessel. By that the pressure will be same. If you see the pressure diagram will be constant, okay, from bottom to top. Ardhamavutunda? Very, very important. So this is your liquid and this is your gas. These statements are very important statement for competitive exams. So please try to remember them. And when the vessels are empty, vessels or a cylinder are empty, nothing is there, it is an empty cylinder or empty vessel, what happens? They are subjected to an atmospheric pressure. By that, what happens, you know, both internally and externally, and the hence resultant effect will be nil. Empty cylinders lo emoutunante atmospheric pressure untundi. So by that, internal and external pressures will be same as the resultant effect. Evana untunda? Resultant effect will be nil. Okay, so this is also important statement. When the vessels are empty, they are subjected to atmospheric pressure from both internally and externally. Hence, the resultant effect will be nil. Okay, so very important 3 statements. Nenu oksa malli statements cheptanu gurtu peట్టుకోండి. When the vessel is filled with gas, the pressure is constant in all the parts of the vessel. Okay. In case of liquid, the pressure is lowest at the top and increases within the depth. And third one, when the vessels are empty, they are subjected to atmospheric pressure both internally and externally, and hence the resultant effect of this at this particular point will be 0 or nil. Em undadu annamata akkada. Okay, so these 3 are very, very important to understand the performance of the cylinders, when the performance of the vessels when they are filled with gases or liquids or, you know, some other kind of fluids. Understand? Yeah. So now let's go into deep. We are talking about the thin cylinders, right? So basically a cylinder or a spherical shell, okay, it's like a ball and a spherical shell, which is going to be considered as thin when the metal thickness is small compared to an internal diameter. Okay, so small thickness untundi compared to an internal diameter, the thickness of the wall will be very small. When the wall thickness, we are going to be considered as a T. Okay, wall thickness ni manam T ani consider chestamu. So let me show you here. So which is equal to or less than D by 20. So where D is the internal diameter of the cylinder or a shell, so which we considered as a cylinder or shell to be thin. Otherwise, it is going to be considered as a thick one. Okay, so like this. Let us take this as a cylinder. Okay, so this is your internal diameter small d, and this is your external diameter capital D. Okay, so whatever the wall thickness, this is called wall thickness, right? So this wall thickness is equal to or less than D by 20. Okay, undanukondi. So where D is a small d kada, where D is a internal diameter of the cylinder or internal diameter of the shell anamata. Shell ante spherical shell. Okay, so spherical shell ante sphere మీకు తెలుసు కదా, sphere is something like a ball. Okay, it doesn't have any longitudinal length. All dimensions are same. Okay, so that is how a spherical ball anamata. So we consider these kind of cylinders as thin cylinders. Okay, otherwise, so when the T is greater than, less than unte idi, or when the T is greater undanukondi, so when T is greater than D by 20 undanukondi, so we need to consider as a thick cylinder ga man consider cheyali. Okay, so here what happens, you know, magnitude of the radial pressure is very small compared to other two stresses in case of thin cylinders, and hence we are going to neglect the radial pressure. See, very important. Ante, before knowing about thin cylinders, first we have to know what are the stresses and pressures are going to be act in the thin cylinders. Hoop stress untundi, longitudinal stress untundi, radial pressure untundi. మనం ఇక్కడ రేడియల్ ప్రెషర్ ని నెగ్లెక్ట్ చేస్తున్నామంట. ఎందుకు? నో నీడ్ టు క్యాలిక్యులేట్ ఆర్ నో నీడ్ టు కన్సిడర్ రేడియల్ ప్రెషర్ ఇన్ ద థిన్ సిలిండర్స్. వై బికాస్ magnitude of radial pressure is very small. ఎందుకు very small చెప్పండి? Compared to other two stresses. Why? Because whatever the pressure is going to act from inside, the resistance of the thin wall, I mean internal wall, will also be same. By that, you can able to neglect the radial pressure which is acting in the thin cylinders. Okay, that is the reason why you are not going to consider or you are not going to calculate the radial pressure in the thin cylinders, because that consideration is very less. మరి ఎక్కడ కన్సిడర్ చేస్తారు అంటే definitely we are going to consider the radial pressure term in thick cylinders. Why we are going to consider there అనేది we will going to study there. Okay, thick cylinders lo we will see it. Understand? Next. One second. Let me arrange this. Yeah. Next, if the wall thickness is less than about 7% of the internal diameter, then the cylinder may be treated as a thin as well. Okay. చూడమ్మా, రెండు విధాలుగా మనం గుర్తుపెట్టుకోవాలి. As we are all writing number of competitive exams, you have to remember in terms of d/20, in terms of percentage also. Okay, ఎప్పుడైనా thickness 7% of the inner diameter కన్నా తక్కువ ఉంది అనుకోండి, that is also you are going to consider as a thin cylinder. And next one, thin walled cylinders are used as boilers. Boiler shells గా యూజ్ చేస్తారు, pressure tanks, pipes, in other low pressure processing equipments అన్నమాట. ఎక్కడైతే ప్రెషర్ చాలా తక్కువగా ఉంటుందో అలాంటి చోట we can able to use these kind of thin cylinders or thin walled cylinders ని మనం యూజ్ చేయొచ్చు. In general, three types of stresses as it develops, as we already discussed that, isn't it? Yeah. So now you can see in a 3D view how the longitudinal stress and circumferential stress is going to be act, and these two are perpendicular to each other. మీరు చూడండి, so these two are perpendicular to each other as they are 90 degrees. Kada? So the stress which is acting along the circumference of the cylinder is called the circumferential stress, where the stress acting along the length of the cylinder is going to be called as a longitudinal stress, which are going to be considered as a longitudinal direction. Okay. Next, the bursting will take place if the force due to internal pressure acting vertically upward and downward is more than the resisting force due to circumferential stress set up in the material. Ante enti ikkada there is a more possibility of bursting force than the longitudinal stress anamata. Okay, ఎప్పుడైనా మీరు సిలిండర్స్ బర్స్ట్ అవడం ఎప్పుడైనా చూస్తే longitudinal కన్నా circumferential burst అవడానికి ఎక్కువ స్కోప్ ఉంటుంది. Why? Because circumferential stress will always be more than the longitudinal stress. Okay, so why? Because the internal fluid pressure is going to affect more towards its circumference. It will try to escape more in terms of circumference than the longitudinal direction. Okay, so which is acting vertically upward and downward, anni directions lo act avutu untundi, avuna? So that is the reason why it is more than the resisting force due to circumferential stress which is going to be set up in the material. Okay, that's why we have to look after, or we have to design your shell, I mean design your wall thickness or design your cylinder to take care of more in terms of circumferentially. Burst avukunda thickness of the wall ni chala important ga manam consider cheyali. If the pressure is more, you should not go with the thin cylinders, you should go with the thick cylinders. Ardham avutunda? So adi kuda manaki we have to know it clearly. Okay, so here you can see the internal pressure and the circumferential stress. Okay, see, if you take the half of the cylindrical shell, so the connectivity, I mean this is the circumferential stress which makes, and this is the pressure. So this pressure will be defined here, and this is the thickness of the wall, and this is your, so last 10 minutes, this is your length of the cylinder. Yeah. Now, how to evaluate your stresses? Sir, how to calculate the circumferential or hoop stress? Okay. So let's see the first important few points and the terminology. So here you can see your cylindrical vessel, right? So where it is subjected to internal pressure, and this is your internal diameter, and this is your external diameter, okay, and this is your wall thickness, and this is your circumferential stress which is acting along its circumference, and this is your length of the cylinder. And if you see the cross section, you can see the cross section also clearly. This is your internal diameter and this is your thickness of the wall. Okay, no need to bother about the external diameter, Amma. Why? Because external diameter is nowhere concerned, okay, for calculating the stress or sorry, calculating the circumferential or hoop stress of the cylinder. Why? Because the internal diameter only is going to resist or is going to affect with the pressure which is acting within the cylinder. Right. So consider a thin cylinder which is closed at both ends. Why? Because without closing at both ends, do you think there will be pressure inside the vessel? No, you have to close at the both ends. E end kani, other end kani, we have to close. Then only the pressure will develop. Then only it is going to be called as a storage unit under. And the open just then storage under we won't. Okay. So that's how the both ends are closed and it is going to be subjected with internal pressure. Okay. You can see that internal pressure in the picture. So let's D is the internal diameter, T is the thickness of the wall, and L is the length of the cylinder. Okay. So this derivation will shows you clearly how to calculate your circumferential stress for the given picture. Okay. So in this picture also you can able to understand it clearly how they are going to be calculated. Anta mathematical. So let's see the derivation, how it was derived to determine the bursting force across the diameter. So sir, what do you mean bursting force? Here, when you are going to calculate your circumferential stress is going to be developed only based on the force. Why? Because we all know stress is nothing but what? Stress is nothing but what? Force by area. Here, what force is acting here? The force is tensile in nature. This tensile force is in the form of a bursting. Bursting ante ee cylinder ni number of pieces ga divide chestund anamata. Okay, that's why it is called as a bursting force under. Okay, so let us take the bursting force which is acting across the diameter. Consider a small length, okay, of your cylindrical, so which is length DL of the cylinder, and an elementary area which is a DA. So let us take a small length of the cylinder as DL, okay, and let us take a small elementary strip of having an area of DA, right, as which is represented in a picture. So when you take a strip, the strip is going to have an angle, isn't it, with respect to its total diameter, so which is theta, and this strip is making an angle of d theta, right? Me andarki mathematics sochu kabatti I think it is very easy to understand. Okay, let us take a small length of the cylinder. Let us take a small elementary strip which is having an area of dA, which is making an angle of d theta, right? So now, so let us first calculate what is the bursting force in this small elemental strip. After calculating the small bursting force in this strip, when you integrate that, okay, you can able to calculate the total force which is acting in the cylinder. Total bursting force man calculate cheyochu. Avuna? Right. So what is dF here? dF is equal to P into dA. Right? Antena? Ela vachindamma idi? Ante pressure is equal to force by area. Isn't it? Pressure anna stress anna okate ani cheppanu kada nenu. Right? So P is equal to force by area. As it is an elemental area, as it is an elemental force, anduvalla dF is equal to P into dA. Okay, that's how it was written like this. Is equal to, what is PM? Sorry, what is dA? So the area, right? So dA is nothing but elemental area. Elemental area in ella rastaru. Elemental area is dl into r. Okay, length into radius of that small radius. Okay, so this is a small r, right? Into d theta. Why? Because this elemental strip is making with an angle of d theta, right? P into this dA can be written as r into dl into d theta. Pressure into, what is radius? Radius is equal to diameter by 2 into dl into d theta. Okay, so this is what your dF. Ante, what is this? Bursting force at an elemental strip. This elemental strip daggara act avutunna bursting force anamata. From this, let's calculate what is the horizontal component of this force. So dFx is equal to P into d by 2 into dl into, so this force ఏ విధంగా యాక్ట్ అవుతుందమ్మా? ది dF అనేది ఎలా యాక్ట్ అవుతుంది సిలిండర్ లో? ఇలాగే కదా యాక్ట్ అవుతుంది, రైట్? Now this dF is going to be distributed, one as a horizontal component, other one as a vertical component గా డివైడ్ చేస్తారు. ఓకే, ఎందుకు? సో this elemental bursting force is acting radially, అవునా? So let us split this force into horizontal component and as a vertical component. So horizontal component of this force is P into d by t into dl into horizontal component enti cos theta into d theta, right? Ade vidhanga, what is the vertical component? Vertical component of this force is equal to P into d by 2 into dl into sin theta into d theta. Andariki ardhamautunda? Clear? This is how the radial bursting force was divided into horizontal component and the vertical component, right? Clear? ikkada varaku andariki ardhamainda? Please, yes, Amma, at least one or two if you respond, so by that I can continue.
Sir.
Right. Now let's remove this. See, anta mathematical, when you come to the derivations, it will be something like, you know, maths. Ante. Yeah. So now, for getting the whole force, bursting force, total force kavali, then what I should do? I should consider the integration of that particular bursting force. Okay. Here, very important. So, me andariki ardham kavali. Sir, out of these two forces, horizontal component and vertical component, which component I need to consider to calculate the overall bursting force? Which force is making which force is making your cylinder to burst? Is it vertical component or horizontal component? Ee ronditlo a component is making your cylinder to get burst? Cheppali. ఈ ఫోర్స్ ని మనం హారిజాంటల్ గా వర్టికల్ గా డివైడ్ చేసాం, అవునా? రైట్. నెక్స్ట్, విచ్ ఫోర్స్ ఈస్ మేకింగ్ యువర్ సిలిండర్ టు బర్స్ట్? చెప్పండి అమ్మా. హారిజాంటల్ వర్టికల్?
వర్టికల్ సార్.
వర్టికల్. Vertical force is making your cylinder to burst. What about horizontal? Horizontal will be considered in terms of longitudinal stress. Ardhamautunda? Vertical will create the radial stress anamata. So by that you have to integrate the vertical force, integration of 0 to pi P into d by 2 into dl into sin theta into d theta. Then man integrate cheste em avutundi? Chudandi, after integration finally you got P into d into dl, where P is the pressure and d into dl is the projected area of the curved surface. Okay. Why? Because D is the diameter and DL is the length of the particular cylinder. Okay. So that's how the total diametric bursting force